In this video, we're asked to write a method called removeEvens that'll deal with linked list programming. So, for example, we're given the following list 421 all the way to 5 here, and we call upon the the method removeEvens. So you can see that we remove the 4, the 2, the 10, 8, 4, 36, 40, and 5, or 40. And we get 1, 5, 7, minus 3, and 8. Or minus 3, 5, and 8. Notice that we have an 8 at the very end. The 8 will just represent that we removed 8 evens at the very end. So, if a list is empty or does not contain any even elements, it's going to be unchanged, except that a node will be added to the very end, which will contain 0, representing that no nodes were removed. Alright, so when dealing with nodes, we have access to the front value, the data field of the node, and its .next field. So let's get started. We're going to use a little bit of recursive tracing here because it'll just make this problem a whole lot nicer and a whole lot easier for us to get through without horrendous nested while loops. So let's get started. We're going to have the return type of void removeEvens. Because we're going to deal with recursive tracing, we want to use the exchangeX property. removeEvens, that'll be our private helper method for this. And it's going to be 0. It's going to take in 2 parameters here. It's going to take in first the front value to tell where we're at on the list, and then it'll take in a value which will determine how many things have been removed. So the initial starting point is at the front, and the initial remove value is 0. So now that we're dealing with our private method, it is going to return list node. And it's going to be removeEvens, not events. It's going to take in a list node. We're going to call that the current list node we're looking at. And we're going to say it's going to take in how many variables have actually been removed. Okay, so we have a special case here. What happens if the current is equivalent to null? I do believe that there was something in the spec talking about that. Your method should also add value to the end. Change. If the list is empty or does not contain any even elements, then a new node will be added containing a 0. Alright, that's what we needed to know. So the current node that we're going to be adding is going to be equivalent to a new list node, and we're going to put in the value of what's been removed so far. Okay. So what happens else after that? Well, we need to check to see if we have data points that are even, and we'll check that by calling current.data and modulus 2 and see if that's equal to 0. If it is, what we want to do is we want to recurse through here and say our current will now be equivalent to the current.next, and then remove value plus 1. Why remove plus 1? Because we know that we've already seen an even value, so we're going to add upon that. And that should be that for that case. This will allow us to make our way through the list by setting current to the next field, and it'll just skip over the evens in this case. Otherwise, if we're dealing with odd numbers, what we want to do is we just want to progress through the list by saying current.next, so we don't modify the current value, is now going to be equivalent to remove evens. We're going to look at the current.next, and we're just going to pass in removed. Oops, struggling. And at the end of this, because we need to return something, because we're returning a list node, we're going to actually return the current node. And that'll be it for this video.